In this video, we want to continue talking about hypothesis testing from two samples. But in this video, we want to talk about hypothesis testing when we have the difference between two proportions. So we've looked at differences of two means, whether it be a Z or a T test, and we looked at the difference between two dependent samples, which was our matched pair. Now we're looking at the difference between two proportions. And this is going to follow very similar to our mean that we looked at in 8.1 and 8.2. So we're going to form a two proportion, and they say Z test, and if you remember, that's going to be on your calculator. It's going to be a two proportion Z test. When you do it on GeoGebra, it's going to be a two proportion Z test also. So our conditions are going to be our two samples must be random. They must be independent, as we talked about. If they're dependent, that was the last section. And with all of these, in order to be able to do this, we need our NP and our NQ to be greater than 5. Now notice we're going to have a whole bunch of these N's and P's because we have our sample size N1 and our proportion P1, and then our sample size N2 and our proportion P2 that we need to deal with. With what we've done to this point, though, this is a small step forward from what we've already looked at. So let's look at an example. In a study of 150 randomly selected occupants in passenger cars and 200 randomly selected occupants in pickup trucks, 86% of occupants in passenger cars and 74% of occupants in pickup trucks wore seatbelts. At the alpha of 0.1, can you reject the claim that the proportion of occupants who wear seatbelts is the same as the passengers, cars, and pickup trucks? So do they wear the same? Is the percentage for people wearing a seatbelt the same in cars and trucks? So first off, we'll say that passenger cars is 1 and pickup trucks is 2. Now, from before when we looked at this, we'll say our P sub 1 equals P sub 2. Are they the same? And then our H sub A is they're not equal to. Now, as you look here, our N sub 1 is 150, and our X sub 1 is 129. So our P hat 1 was 86. That's what was given. So as you notice here for our second one, we have 200. Our P hat 2 was 74. And so we have to figure out our 148. So depending on what you have will depend on how you do this kind of problem. So they gave us 150 in the problem, but they said the number was 86%. So if you have that, you have to figure out the 129. If they give us 200 and they said 74% wear the seatbelt, we need to figure out the 148. And that's important because when you do this on the calculator, for those of you with the TI, we're going to go to a two proportion Z test. You can see we need X1 and N1 and X2 and N2 to be able to do that. So you need to figure out what's the X and the N. You don't need to figure out what the P hat is. The calculator doesn't care. However, those of you that are going to do this on GeoGebra, you remember when we looked at proportions previously, the GeoGebra doesn't use our X1. It uses our sample proportion 1. So they use P hat 1. So sample size 1 is our N1, and then our sample proportion 2. So the computer uses our P hats. The calculator uses X1. So however you're doing it, whatever you need to use to get your information, it depends. So in this example, they gave you the P hat. They gave you the 86%, and you had to find X1. Once we type those in, whether it be the calculator or the computer, we get a p-value of 0.0062, which is definitely less than alpha. So we will, if it is less than alpha, we will reject H sub O. And there we'll say there is enough evidence to support that proportion of occupants who wear seatbelts is different from passenger cars than trucks. Doesn't necessarily say which one's higher or the lower. All we're testing at this point is, are they not equal? Let's look at another one. Medical research convened a study to test the effects of cholesterol medication. At the end of a study, researchers found 4,700 randomly selected took the medicine, 301 died. Of the 4,300 who did not and took the placebo, 357 died. Can you conclude the death rate to heart disease is lower for those who took the medication over those who took the placebo? Notice here, they give us our X1 and our X2. They don't give us the p hat. So we would have to calculate our p hat. So for those of you doing it on the computer, you would need to go then to the computer and take, or the calculator, and take 301 divided by 4,700 to get your 0.064 as your p hat, so that when you went into the calculator, you could type in, or the computer, you could type in your p hat. So you can do it either way. It just depends on which one you're using, on whether or not you need X1 or you need p hat 1. We type this into our calculator, into the computer, and you can see our p-value is very, very low. That means we reject H sub O. So that means that P1 is definitely less than P2. So we say there is enough evidence to support that the death rate for heart disease is lower for those who took the medication. So this section, when we're finding the difference between two proportions, when we're using our our two proportions, and we're doing our two sample test, two sample Z test for a proportion. On your calculator, you're using the two sample number 6, two proportion Z test. For those of you that are using it on the GeoGebra, here is yours. It's a two proportion, two test. And remember, you need to use the p hat.